Okay, on to example 2 here. Find all the points on the graph of this for which the derivative is 0 and for which f prime of x doesn't exist. Alright, so we're looking for points, that's important. Um, so let's see, I think what we're going to have to do is find the derivative since it's telling us to. Alright, start with your function, rewrite it. Alright, so then instead of writing cube root, we'll write to the 1/3 power, but now if it's squared times the 1/3 power, we can write it as 2/3 power. Alright, now we're going to use the power rule and the chain rule together. So f prime of x then becomes 2/3 times that function okay, to the negative 1/3. We subtract 1 from the power, and we can't forget to multiply by the derivative of the inside, which will be 2x. Alright, so it might help us to rewrite it a little. 2 times 2 is 4. On the top, all we have is an x. On the bottom, we have 3 times, looks like cube root of x squared minus 1. Alright, so there's our derivative function, so we need to figure out where the points at which it's 0 and when it doesn't exist. Alright, so f prime of x, when is that equal to 0? Well, all we have to do is set our numerator equal to 0. So 4x equals 0, and what would make that 0 but x equals 0. Okay, x equals 0. Alright, so what point would that be? If we take 0 and plug it into our function, f of 0 equals, plug it in, we get negative 1 squared, which is just 1. Cube root of that is 1. So here, at this point, 0, 1, our function, or f prime of x would be 0, or we have a slope of 0 there. That's for the first part. We are now looking for where the derivative doesn't exist. And so that's going to be where our denominator is 0. X squared minus 1. Okay. Where is that equal to 0? Alright, and so if we solve this, there's going to be 2 places where this would be 0. So we divide by 3, we cube it. Okay, and we could factor this or just solve it. Either way, you get x equals plus or minus 1. Alright, so we're talking about 2 different points. It would be at 1, plug that in. Looks like we're going to get 1 minus 1 is 0. Okay, plug in negative 1. Square that, minus 1, it's 0. So these are the points where f prime of x does not exist. Alright. Let's move on to example 3 then. Show that the slope of every line tangent to the curve is positive. So we're talking slope, tangent, that means derivative here. Alright, so let's start off rewriting our function. Instead of writing 3 in the denominator, I'm just going to write it as a power of negative 3. Come on. 2, 2. Alright, so negative 3. Now I can use the chain rule here. So the derivative would be negative 3 times that function, 1 minus 2x to the negative 4. And I'm not done yet. Alright, times the derivative of the inside, which would be negative 2. Okay, if I combine this now, I'm going to negative 3 times negative 2, that's 6. In the denominator, I'm going to have 1 minus 2x. And this time it would be to the 4th. Okay, in this case, this function, it's never going to be negative, because when you take something to an even power, it always ends up positive. So what conclusion can we draw from this? Now, it's hard for me to write, so I'm not going to write too much. I'm going to speak it, and it's your job to write it down. Alright, all the slopes of every tangent line to this curve are positive. Okay, and except at what point? 1/2, because if we make x 1/2, this bottom's 0, and the function, the derivative is undefined, and so is the function. So for all slopes of f of x are positive, except at x equals 1/2. Alright, so we could say that since the slopes are all positive, the function is monotonic increasing, or strictly increasing over its domain. Okay, so your job is to write that down. F of x is strictly increasing over its domain because all of the slopes of the function are positive. Okay, let's check out number 4. Alright, this will take a little bit of algebra, but you're in calculus, so you have those algebra skills. Alright, I'm going to make this pen a little bit skinnier so I have room to fit it all. Alright, so find dy dx, then simplify it. Alright, so I guess we're going to, maybe I should rewrite it first. Let's see. Instead of writing it that way, I'm going to write it up here. Y equals x squared times 1 minus x squared to the 1/2 power. Alright, so now I'm going to be taking the derivative, so dy dx equals our product rule time. First times the derivative of the second. Alright, so be careful here. It'll be 1/2 times that inside part using the chain rule. Squared. Okay. Come on. Then subtract 1 from the power, minus 1/2. Times the derivative of the inside now, which would be negative 2x. So we're done, right? Of course not. So we did the first times the derivative of the second. Okay, plus the second function. And that's through the 1/2 times the derivative of the first, which would be 2x. Alright, before we start simplifying, we should probably clean up a little bit of this. We have 1/2 times 2. That's just 1. Alright, we have a negative. We don't want to forget that. X squared times x cubed. Okay, and so the only thing we have left is this part, 1 minus x squared to the negative 1/2 power. Alright, on the other side we have plus 2x times, come on, 1 minus x squared to the 1/2 power. Alright, so we're simplifying by factoring out the least power. What's the least power you see here? There's only one that's negative, so it's got to be that one. Alright, so we're going to factor that out. And now is when you need your algebra skills. So we take this out. Alright, and I wish it wasn't taking me so long to write this, but oh well, I have to deal with that. And so do you. Alright, so what's left here? So we take out, we can take out an x too, right? There's an x on both of these. Alright, so now what's left over? It looks like on this side it's just going to be negative x squared. That's not too bad. We took out the x. We took out a negative 1/2. So what would we have to multiply by a negative 1/2 power to get the 1/2 power? Okay, and that's just going to be a 1. Alright, so the only thing I'm going to have left here, 2 times 1 minus x squared to the first power. Alright, so think about it. If you multiply this back out, negative 1/2 plus 1 gives us 1/2. Alright, if you need help with the algebra, just talk to me in class. Alright, and it looks like we can simplify this in here. 2, this would be 2 minus x squared. Alright, so we have x times 1 minus x squared to the negative 1/2 power. And we get 2 minus, alright, minus 2x squared minus 1x squared minus 3x squared. Alright, and the only other thing we could do, let's just rewrite it maybe as a fraction here. Okay, we get x times 2 minus 3x squared, come on, x squared up there, okay, over negative 1/2, so we have square root of 1 minus x squared. Now this could be really useful to write it this way. We can immediately find out where it's undefined. We could find out what the zeros are. So this is a very functional way to leave our I can't think right now, our function. There we go. Okay. So this one here, my pen isn't working out too well, so I think it's going to take me 10 minutes just to try to write this. Alright, so I do want you to try it, but as you can see, my pen's just freaking out. My computer's going too slow, doing too much math. Alright, so I'm just going to start out by rewriting this for you, and I want you to try to go ahead and use the product rule, use the power rule, use the chain rule. Okay, and this would be to the negative 1/3 here. See if you can end up, this is what I ended up with. F prime of x is, I ended up with 1/3, that's a 3. Alright, 1/3 x squared plus 4 all over cube root of x squared plus 4 to the 4th on the inside. Alright, see if you can try it. We'll talk about it in class if you have any problems.